talked about long division, and we worked through those long division problems, and this is the last problem we did, right? And we actually found out that x minus 3 is a factor of x cubed minus 2x squared minus 9. We found that out perfectly. But we had to do long division to do that, right? So you don't always have to do long division. If it's an easy thing to set equal to 0, if what I'm dividing by is easy to set equal to 0, I can actually use synthetic division instead. And you probably remember synthetic division from Algebra 2, but we're going to go back through those steps again. But most of you like synthetic division because it's pretty easy. Okay? So what we're going to do first, and always step 1, if you can, is to set that equal to 0. If you can. Can I do this one pretty easily? Can you set that equal? Yeah. Trevor, if that was set equal to 0, what would x equal? Okay. He did that in his head, right? That was a simple one that we could set equal to 0 very quickly, very easily. Now, I know some of you are writing, but I'm going to go back a slide real quick. Could I have done this one? I can't set that whole thing equal to 0 very easily, right? So I have to use long division on it. But since this one is easy to set equal to 0, I get to use synthetic division. So what you do is you put 3 in a box. Now it all depends on who's teaching this, just so you know. Sometimes they don't put the box there, sometimes they do something different. It's still the exact same process. Now what I need to do is I need to give the leading coefficients of all of these. That includes any variables that are missing. So I see 1x cubed. I see negative 2x squared. How many x's? 0. And then I see a negative 9. Now, I always like to have a quick double check. Okay? Not the discount double check like you hear on TV, but a quick double check to make sure I have enough numbers. So what's my degree of this polynomial? 3. What's 3 plus 1? 1, 2, 3, 4. That's how many I should have there. Take the degree plus 1. That's your quick double check right there. That make sense? Okay. So I like synthetic division because it's actually a little shorter. Step 1. Bring down the first number. And now you get to do only 2 operations. And they're actually my favorite 2 operations. Multiply and add. I don't like dividing, I don't like subtracting. So multiply and add. Multiply. 3 times 1 is? Add. Negative 2 plus 3 is? Multiply. 3 times 1 is? Add. Multiply. Add. Okay, now notice I put the last number in a box. That is my remainder number. Well, we found out yesterday doing long division, the remainder is 0, right? So we already knew it should be 0. But they want me to rewrite the polynomial, not just 1, 1, 3. Well, what was your degree again? 3. And take 1 away from that, that would be 2. So this is going to be 1x squared. And it's a positive 1 here, right? So I'm going to put plus 1x plus 3. If it's a negative, I change it into a minus sign in between them. That's all I do. So all I did was I took 1 away from the degree to get this 2, and then I just circled down. So x squared, x, regular number. That's the exact same number you got yesterday. But can you always use synthetic division? No. So that's why we purposely made sure you could do long division, because you can't always use this. But when you can, I say go for it because it's easier, right? Okay, so let's make sure you've got synthetic division down. Here's a new problem. Take a minute and do your synthetic division. So as I was walking around, I saw a lot of different answers. So everybody was trying it, but it seems like we're making a few small errors. So let's see if we clean that up. First off, if I set this equal to 0, what do I get? Negative 2. So I'll put that in the box. I have 5x cubed. How many x squared? Negative 2 x's and 3 regular numbers. Bring down the 5. You get negative 10, add, multiply, add, multiply, add. Is that what you guys got?
Yeah.
Okay.
How did you get oh my god.
Someone fixed it? That help? Okay, so now I need to rewrite my answer as a polynomial though, right? So it should be 5x squared minus 10x plus 18. Uh-oh, but there's a remainder. So remember yesterday we talked about how to write the remainder. Plus negative 33 divided by, what exactly did we divide by? X plus 2, right. X plus 2. So that's how I write my final answer. That makes sense to everybody? Okay. Is x plus 2 a factor of that big thing? How do you know no? You guys are all right. How'd you know? Leanne. Good. If there is a remainder, then it's not a factor. That also means, just so you know, that the number negative 2 is not an x-intercept. You just proved it's not an x-intercept. On the last one, you actually proved 3 is one of the x-intercepts. How cool is that? That's another way for us to help with the graphing. Okay. So we're going to use the remainder theorem actually to evaluate f of negative 1. I'll give you a minute to write that down. So if you remember back to Algebra 2, we actually did this type of a problem in Algebra 2. And what you can do is synthetic division with the negative 1 and using this number. So I'd like you to go ahead and do synthetic division. You're going to use negative 1. And you're actually going to go ahead and synthetically divide. Go ahead. Go ahead. So I'm going to go ahead and do my synthetic division with negative 1, 4, 10, negative 3, negative 8. I hate that you guys know this. 4, negative 4, 6, negative 6, negative 9, 9, and 1. Did you guys get that? So, was that very hard to do? Okay. And actually what that tells you is that f of negative 1 is equal to 1. If I plug negative 1 back into that original equation, it would give me the number 1. But I would have to cube it. I would have to multiply that by 4. I'd have to square it. I didn't have to do any of that, did I? The remainder theorem actually gave me the answer quickly. Also, by the way, does x equal negative 1? Is that a 0? Is that an x-intercept? No, why? You're right, Justin. Good. If it was 0 here, it would be a 0, right? That's actually why we use the word 0 also as an x-intercept. Okay. We're going to factor this. And I'm going to tell you one of the factors is x plus 3. So what we just talked about was setting the x plus 3 equal to 0 and synthetically dividing. Now, did we have to do synthetic division? Could we have done something else? We could have done long division, right? But like we just found out, if it's easier to synthetically divide, go ahead and do that. So I'll set mine equal. I get negative 3. Now, since you know that's a factor, what should you get as your remainder? What if you don't get 0? Then you did it wrong. I like that. You know immediately, if it's telling you it's a factor, well then you know if you messed up or not. So 1, negative 3, 9, negative 10, 30, and 0. So I'm going to rewrite this as x squared minus 3x minus 10, right? Okay, can you factor that using just regular factoring skills? Okay, go ahead and factor it. Remember, when you're factoring, you're asking yourself, what times what is negative 10? But add to negative 3. You're adding 0 plus negative 3 is. That make sense? All right. I did the beginning part of the factoring. The easy part, right? Brandon, what'd you get?
X equals -2.
Wait.
Oh,
We're just factoring, so you don't want to give me the equal part.
X plus 2 or X plus 2 and X minus 2 is 5.
Good. When you're factoring, you leave them in the parentheses. Now, if I FOIL these two, just these two back together, do I get the original? No, I'm missing a whole X, aren't I? Right now I only have 2 X's, but I need 3. Where's where is it? The X plus 3. That is the complete factored form. By the way, you can have these in any order. You could have X plus 3, X minus 5, X plus 2. You could have the X minus 5 first. You can have it last. Whatever order's fine. If I said find all the zeros instead, what would they be? Good. You have to make sure you retell me that -3. Does that make sense? So this is factoring. And then your zeros are negative x equals, let's do x equals, -2, -5, and +5, and -3. Does that make sense? So I wrote both of those down so that in case your homework asks you for zeros, you actually give me x equals. If it says factoring, you give me parentheses. Give me a second. Everybody good? Okay. Now, since we took actually like 2.5 days on this, right? You actually get the rest of the period to work on the homework, which is about 20 minutes. There you go.